the last day for the summer school. Actually, we already have sessions this morning. The first one is given by Frederic on SDN and NFV. While he's getting ready. Okay, then afterwards we have 2 more presentations on network orchestration and management. Before we can all leave the summer school. So Frederic, we have roughly 1 hour, and I give you then 5 minutes.
So thank you for having me. So I'm Frederic Francois from Imperial College. So I'm going to present some work on SDN and NFV Orchestration for optimized network services in 5G phone networks. So before we continue, I would like to point out that we are quite early in our research. So this is not really a finished product, but just some discussion, some promote discussion, and it's a peer review. So if there's any mistake, excuse me. So this is the outline. I'll give you a little background. So basically, we want to concentrate on the use case. So our use case, what we want to concentrate today is functional roaming models. So then I will present our objectives, network layers, different service provisioning options for roaming, comparison of service provisioning options, problem formulation, a very simple heuristic, not much in detail, and some remarks and conclusion. So I think, as you well know, like many mobile subscribers, we are using different networks rather than their home mobile network, either because they're traveling to different regions or countries. So during that time, we do either fractional roaming or we just get another SIM phone or something like that. Or we can also use Wi-Fi networks because we can have higher speed and lower latency, and probably at a marginal cost or no cost at all. Sometimes it's sort of free. But subscribers also want to keep the same number of services as in the home network, and they want to keep a quality of service that is provided by this home mobile network. And also we want to minimize costs. We don't want to buy another SIM and get another contract, these kind of things. So in case we look at how sort of NFV and SDN can help them in that sense. So the casual roaming models, what typically we have is a home routed. So these casual roaming models is like for data. So the home routed is where all the data traffic from a existing subscriber are routed back to their home network. And it is a home operator which is supposed to do all the services, which is supposed to deliver all the services. So the visitor network only provides the video access path, and all the backend is provided by the home network. So you have now the local breakout in LTE also, where all the data traffic from visiting subscriber are serviced by the visitor network. But it is the home operator which builds the subscriber. And interestingly, now in Europe, since 2014, there has been a new regulations law where you can have an alternative roaming provider. So basically, you keep your SIM, but you get a contract with another provider in the country that you're visiting, and he's the one providing the services and billing you directly. But you keep a SIM and you keep a number, so it's sort of ideal in a sense. You don't have to change the SIM card. It's going to be a new number. But these roaming models are too inflexible, I think, and there is room to optimize both quality of experience and cost. So our objectives is like we want to design an architecture where a home mobile operator can offer same or better services to its customers when we are roaming or using over Wi-Fi networks. We need to have a framework to monitor the service usage and QoS that mobile subscribers are having on the visitor network, so that we can build and do different kind of optimization. So we want to optimize the mix of home and visitor network provided services so as to enhance the quality of experience and cost to subscriber home network operator. So a very simple network layer, I know that NORMA has much more elaborate ones. So here, okay. So here, okay, usually you have an access network, so it can be cellular where you have like 5G later on, and LTE now, and 3G. And you then have like Wi-Fi network, so you have cable. And then on top of that, you have your core network. Well, the core network is mainly based on compute storage network, and then you put your virtual network functions on that, and then you get the different functions in order to provide top-level services, which is like internet connectivity, voice calls, SMS, protection against malicious websites, these kind of things. But obviously, I mean, as you go down at this layer, this is where most of the investment are being done. So, okay, because it's more distributed, it takes a lot of time to deploy this kind of thing. And when you go up, it becomes like the capital cost is less intensive and it's easier to deploy. So probably a lot of people like to operate on top of here because, okay, this is where we can make the sort of most profit without investing too much. So we have like 3 provisioning options in our scenario. So the first one is service is provided wholly by distant network, which is like similar to the identity roaming provider, distant provider. And the second one is the operator provides service by deploying virtual network function inside a distant network infrastructure. So home provided is distant, I will name it this way. And then we have services provided by home network operator, so home provider. Okay, even if it is provided by the home operator, you still have to have the network needs to provide the access network because we don't have it there where the user is. So that's why the user is actually roaming. And the network will have to be compensated for that if there's all money. So the real thing is for each service that the home operator wants to provide to its subscriber based on dependencies. So therefore we cannot really sort of allocate them just randomly or just according to cost. So therefore like you will have some kind of service chains due to these dependencies between services. So these service chains will have to be located together in some sense. So just a comparison of different service provisioning options. So if it is distant provided, so it's less complicated. The home operator just buy the service from the distant network and provide it to its own subscriber, which is roaming. Likelihood of better QoS because all the infrastructure is local there. So it's like you're not rerouting back to the home network. So there's likely to be less latency, these kind of problems. So better QoS, probably. And then short provisioning time, so you're just buying a service, you're not provisioning a new VM or new stuff. So probably these services are already provisioned and you just share the services. You don't have to provision your own virtual network functions. Probably cost more because as you look at the chain value, you will like this network will charge more for these things. Some services may not be available on the distant network. So then, okay, you have to find an alternative way of providing these services, or you just tell the subscriber that this is it. I mean, you should have these services on this network. You have to do like careful monitoring also, because obviously now the distant network is providing all the these services, and you have to monitor that these services are being delivered with the right QoS, so that okay, you're not wasting your money. And in the home provided invisible network, so you have to deploy your own, the home operator has to deploy its own virtual network functions inside the visible network. You can have more control on QoS because you're provisioning your virtual network functions. You know how these virtual functions are behaving, you can monitor them, you have full access to them. Most secondary services can be provided. So if we sort of believe that virtual network functions can provide most of the services, so you can just deploy these virtual network functions and provide these services to your home servers who are roaming. But it's complicated. Basically, okay, you need to find where your subscribers are in this system network. You need to optimize where you're going to place your virtual network functions. Okay? And also it's a long time to provision. For example, for a virtual machine, it takes a lot of time to provision. Okay, you can still have like containers, Linux containers, which has less time to provision, but we can suffer from some security stuff compared to virtual machines. And can be expensive if not enough customers. If you have a couple of customers in that distant network, okay, if you are deploying a couple of virtual network functions where in order to give services to them, maybe there is not enough customers to cover the cost. So in a co-provided one, we can have like, okay, more control on QoS, okay, because okay, you have full control over the infrastructure. Okay, but okay, there is some caveat on that because the radio access part is provided by the distant network. All services can be provided, and less complex, obviously, plus low cost, because basically most of the cost is internal cost. Okay, and then, but the disadvantage is you have to reroute traffic between networks. So depending on the link between the distant network and the home network, this can impact on the QoS. So it may not work in some cases. So our simple problem formulation for now is we want to minimize the total costs associated with providing services for roaming subscribers. So this is with respect from a point of view of the home operator. But we want to maintain the QoS matrix within the service level agreement bounds. So how we are going to do that? So what kind of information what we have? So in the home network, we have user profile. From a user profile, we have the services subscribed to, along with the service level agreements and cost to the user. So then, like, okay, you have some kind of limits on bounds. So you have to respect the service level agreement, and there is some cost also. So which you need to be below. So the cost to the home operator needs to be below that, so to make a profit, or you can sort of agree that when he's roaming, maybe there will be some extra cost, but it needs to be within some bounds. So the visitor network, so what can he provide? So you can provide some different services. Here we assume that for the physical machines where you can deploy VMs and also traffic steering with SDN, it's a service. So a service where, okay, it has a service, it has a provision time, how long it takes to get this ready. It has some QoS metrics, and it has also some cost with it. So services can be primary. So how I define primary services is, okay, it's just some basic services on top of which you can build more complex service. For example, a primary service will be connectivity between the business and home network. So instead of much use to the end user itself, but on top of that you can build some more service which the user actually needs. And also another example of primary service is resources to run virtual network functions. Okay. And a secondary service example is protection against malicious websites, where you have to use a combination of virtual network functions in order to provide this secondary service. We also need to have some QoS monitoring. So both home network will have to provide frequent updates on the QoS of the services that they offer to the roaming subscriber and to the home network. So this verifies that we are still within the QoS bounds and still meet the service level agreement. And then, and also if these SLAs are being violated, we need to have some technical remedies to bring the QoS within SLA bounds. Okay, we can use this QoS and use this information for effective delay also, because we want to verify that the user network, for example, is providing the services that it is safe to provide. And also there needs to be some kind of penalties if the service level agreements are being violated too often. Okay, it can be different type of penalties. So just a basic heuristic, well, it's not really a heuristic, but a decision process. So whether we are going to allocate how we're going to allocate a service to a provisioning option, to one of these three provisioning options. So usually the home provider or operator will get the roaming subscriber home services and the SLA, they agree that and the cost also. While respecting dependencies, we need to separate these services with the service chains. Okay? And then with these service chains, when we get these service chains, we need to augment them over three different provision options. But what word augment is, what I mean by that is, for example, if a service is going to be provided in the home network, now in the service chain, we need to include the fact that we need to pay for the connectivity between the distant network and the home network. So we need to add this to the service chain. Makes sense. And also for a given service chain, we need to only eliminate the provisioning option which doesn't meet the SLA QoS bounds. Okay. And then after that, we choose the remaining option, which is the cheapest. So some remarks. With this heuristic decision process that I have explained in the previous slide, it's a very simple one, quite a simplified version. So some remarks is that each operator may have to re-optimize placement of network virtual functions in its own network depending on distribution of subscribers in its network, services the subscribers require, and the usage of such services. I think this will be talked later in the seminar when we do like that, or yesterday where we had dynamic virtual functions allocation. So the cost also, here like before we were assuming that the cost associated with buying or providing services is fixed. But actually the cost is varying with time, and since the infrastructure usage varying with time also, and the cost need with providing services needs to vary to reflect the basic scarcity of resource. So then we have to re-optimize over time also. Third point, there is only one external service provider now in this architecture, but probably there will be much more providers later on. Even for the services which are provided by the home network to its own subscribers, some of the services would be basically handed over by some other service provider who is going to provide this service rather than the home network, but the home network is still billing its own customers. So this happens like in networks nowadays, but it's not very dynamic. Probably with NFV and SDN, this will be much more dynamic when you have a marketplace. So fourth point is we have different service providers with different QoS metrics, because we have different way of measuring QoS, and we have different cost structures also for a given service. So in order to make a decision, we need to convert to a common set of QoS such structure in order to do a comparison. So it's sort of normalization. So conclusion is we can have part of home operator services being provided by home operators to reduce costs, bring extra revenue for home network while providing quality of service to its improving quality of experience to its subscribers. We can maximize benefits for the home operator if they can carefully optimize which provisioning model options can be applied to which service chain. Finally, cost usage distribution of services can vary with time, so we need to optimize. So here we are mostly currently working on the how to do this thing. So how do we do separate services in the service chain? So how to do this efficiently and while also being correct in terms of dependencies. This is our main bulk of our project right now, but we haven't finished yet. And then also here to choose the remaining option, which is the cheapest, sort of different makes sense because, okay, for example, in the home provided services in the business network, you have to deploy the NFV to this kind of thing, and depending on how you deploy your NFV, how efficient you are, so the cost here may change. And it varies with time also, depending on how many customers you joining the business network also. So this is another program we are looking at currently at Imperial. So thank you if you have any questions.
This is very well ahead of time.
I have a question. In the Europe, they will soon get rid of the roam charge. Will this have any effect on what they are planning to do here?
Yes. I think it's getting down. The roaming charge is getting down. So in Europe, but I think here. So it's getting down, but like usually you can have like agreements. So you're charging your customer. I'm an operator in UK. I'm charging my customers a fixed amount. And now if, for example, Europe say now it needs to include all the services in Europe also, and it needs to include on my package also, still using my allowance. So what happens is a home operator has a dilemma. So it needs to buy these services from a business network because it doesn't have the infrastructure that radio access part there in order to provide this. So you need to buy this service there. So then you have to optimize in a sense because you have the cost, but you can sell it to customers, to subscribers, and you have the cost, but you can buy the services from other providers because you're going to provide it yourself. And at this gap, we need to optimize this gap. The bigger this gap, the more profits what you have. So in a sense, it keeps this scenario.
Ladies first. Can we see this first?
So two questions. One is the fact that let's say the roaming, the income from the operators is going like this because people uses internet and maybe Wi-Fi, and they use Skype and all those means, which I use as well, to avoid roaming costs.
Yes.
So is roaming, first of all, still a very important problem? This is maybe one thing. And second is about this alternative that you had on the third slide, alternative roaming model, where you say that the service is provided by the visited network. In this case, do you have one billing system, or is it I need to?
2 billing system.
2 billing system.
2 billing system. So you need to pay extra. So you have a contract with your home network, for example in UK, and when you're visiting there, roaming there. You can have another contract there also, but you keep your SIM and you keep your number.
So I need to go to whatever shop or whatever network operator and buy another service, which is not very convenient.
Or you can do it online, some people can do it online. But okay, I looked at it in detail, but okay, according to the law in UK or well, in Europe, this is supposed to be provided since regulation 2014. But actually, it's not, okay, but alternative roaming providers is not, there's not that many people who provide it outside.
What are the services you're thinking of in this case?
So, for example, we can have services for the, that's why I think, okay, in this sense, some telco can have some added services in order to, for people not to go to Wi-Fi networks. So, for example, okay, in your Wi-Fi networks, you're not very sure about the security. So your home operator can do some security mechanism in that Wi-Fi network. But okay, it's still provided by the home operator. So it verifies that this Wi-Fi network is actually secure and can provide other services also.
This is still internet access.
Yes, it's still internet access. So, but internet access, but with other services. For example, you can protect against malicious websites. For example, you can have a DNS service. A DNS service where you will have a list of malicious websites that you are maintaining, and each time the subscriber is trying to go or rerouted to this malicious website, the DNS service provided by the home operator could be that because it's on the blacklist, this website is on the blacklist, it will not convert this website name into the IP address.
Maybe it would be useful to think to other services rather than internet access.
Yeah. I mean,
like if you think to car to car, for example, if I'm roaming, so if I have my subscription with my, let's say, home PNMN, and then I go abroad, then I don't want to make. I want that. Of course, it depends whether in the SIM or not. But I want that. Say I go through my countries, for example, in Europe, and still my card works with the device would work. Maybe it would be good to focus more on these new services.
Yes, I mean, in a sense, okay, I mean, this is like what actually roaming is being done right now, I mean, cultural roaming. So now, okay, if you have your SIM in UK, for example, you can go to any countries in Europe and still use it and get some services like internet access, calls, SMS. It's just like usually it's quite expensive. In a sense. I mean, it's still done in Europe right now. I mean, what we are trying to do is, from a home operator point of view, is, okay, I mean, I don't have an infrastructure there in these other countries to provide a radio access part, and I want to rent this, what are these? Like I can rent this slice or something like that. So how do I rent this slice? And what other services should I rent from this service provider, from this Uber provider? So this is the optimization what we are trying to do.